In this video, we are going to look at properties of ionic compounds. We want to know what are the things, what are the features or characteristics that can describe ionic compounds. We are going to look at least 4 general properties of ionic compounds, and the first one is they are usually crystalline solids. Take note of the word usually and crystalline solids. In most cases, these ionic compounds are solids and in some cases liquids. However, they are crystals. That's why we are saying crystalline. Remember, a solid can be either crystal or amorphous solid. And in this case, a crystal, we are meaning a solid that has a regular arrangement of atoms. So ionic compounds are usually crystals, just like you see salt crystals. One thing you'll notice that if you go to your kitchen and try to find sodium chloride, which is our table salt or common salt, you'll find it in form of crystals. And this is true for all other ionic compounds like calcium chloride and potassium fluoride. As you can see, we said ionic compounds, it should be a metal and a non-metal. Most of them will appear in the same way, and it may be hard for an individual to tell which one is which because they all appear crystalline. So ionic compounds are usually crystalline solids at room temperature and pressure. Property number 2, ionic compounds have high melting and high boiling points. Have you ever tried heating salt at home? You will realize that actually salt takes quite some time for it to start melting. This is because in a salt crystal lattice, you have to apply a lot of energy for you to separate these ions from one another. The positive and negatively charged ions are being held by very strong forces of attraction, and in this case you'll have to apply quite enough heat for you to pull these ions apart. As such, it will always require a lot of thermal energy to overcome, and hence we shall always have high melting and boiling points compared to covalent compounds like water. Number 3, ionic compounds are usually soluble in water. We know water is a universal solvent, but they are insoluble in organic solvents like petrol and kerosene. I'm quite sure all of you have ever added salt to water, and you'll realize that after some time your water will be as clear as before, and that's because the salt will have dissolved in the water. So when you look at common salt, sodium chloride can dissolve in water, so will other ionic compounds. They will be able to dissolve in water. However, in petrol and kerosene, please give it a try. They will not dissolve. Your salt will not dissolve in oil. So one thing to note is that water is partially ionized. That means it is polar. So when you look at a water molecule, it will have some partial charges on it, partial negative and partial positive. And when you look at our sodium chloride, we shall have sodium ions and chloride ions. So these charges will always be able to interact. And there is a saying that always like dissolves like. So in this case, like water, which is polar, is also dissolving like sodium chloride or the ionic compound, which is also charged. So like dissolves like. In this case, our ionic compounds will be able to dissolve in our water. So when you look at salt in our glass, it will be very clear. It will be hard for us to see it because it will be able to dissolve. However, when you try to add it into our oil, it will remain insoluble. It will not dissolve in our cooking oil. So for that case, we can say they are usually soluble in water but insoluble in petrol. Lastly, our fourth property, ionic compounds conduct electricity when dissolved in water or when melted. In this case, whenever you dissolve an ionic solid, say sodium chloride, we shall stick to that, you'll realize that in water, the crystal will be broken down into its corresponding ions. So we shall be having sodium ions and chloride ions in water. And it's these ions that will always help in conducting electricity. That's why when you have your pure water, you realize that pure water will not be a very good conductor of electricity. However, when you add salt to it, it will easily conduct electricity. So this is basically because the ions are free to move in solution, that is to say when dissolved in water, or in molten form, that's when you have melted our compound. So if you try this setup here and you try to complete the circuit using our salted water, you will realize that it will actually conduct electricity. With the help of the bulb lighting, it will show that actually there is flow of electricity. So those are our top 4 properties of ionic compounds. As usual, I will end it with our top 3 questions. Number 1, why do ionic compounds conduct electricity when dissolved in water? Number 2, ionic compounds are insoluble in A. Kerosene, B. Petrol, C. Both A and B, and D. Neither A nor B. Then lastly, ionic compounds have low melting and boiling points. Is this statement true or false? Please let me know in the comment section below. Once again, thanks for watching. Please don't forget to like, share, comment, or subscribe if at all you find these videos helpful to you. In our next video, we shall look at covalent bonding as our next type of bonding. Be well.